So 4.2 is over our old friend arithmetic sequences, and I love arithmetic sequences because they're just linear, and we've done linear forever and ever and ever, and we feel super comfortable with them. So this should be a kind of a nice review before we move on to arithmetic series, which is a summation of arithmetic sequences. So I think that this will lead nicely into that. So a sequence is just a series of numbers, right, where you're doing something to get from one number to the next number, whatever that pattern may be. We were looking at those last session. So let's say I'm looking at this first set of numbers here. My first term is 7, 14, 21, 28. So there's clearly a common difference. That's what we call it sometimes, the sequences. Or you could say a slope of 7 per 1 increase. So we have written recursive equations in the past. You can say that I get to my next term by taking my previous term and adding 7 to it. It's a common difference. You'll see that this number shows up in both recursive and explicit notation. And then we say that we started at some specific number. Well, what number did we start at? In this instance, our first term, a sub 1, was 7. Okay, let's look at this one. 2, 11, 20, 29, 38. So I have a common difference of positive 9. Recursively, this is a sub n equals a sub n minus 1, the past term, plus 9, where I began with the term 2. Boom. One more we're going to look at recursively. 48, 39, 30, 21. I'm losing 9 or adding negative 9, depending on how you want to express that. So to get from my previous term to my next term, I subtract 9 with an initial term of 48. So those are all written recursively. Explicitly, the easiest way to think about these is y equals mx plus b, right? Where I'm talking about a common difference times the placement of my term, and I'm adding some output that is associated with the 0 term. So if this is my first term, then my 0 term would be 7 previous to that, which would be 0. So 7 is my common difference, slope x plus 0. You may also see this written as a sub n equals 7n. That's what this is right here. Okay. Here I have that my output of my nth term can be found by taking my slope or my common difference of 9, multiplying it by n, the placement of that term. And if I go back 9, I can see that my 0 term is negative 7. Boom. Last one, a sub n is equal to negative 9n plus 57. One back. If you want to do a try it, I'll give you a pattern. Let's just make it a friendly one. 50, 43, 36, dot, dot, dot. I want you to write both a recursive and an explicit for practice, and then we can check them when we come to class. Arithmetic sequence. It is arithmetic if there is a constant d for which the next term is found by taking the previous term and adding d to it, right? It's my constant additive difference. The nth term, or the term that I may be looking for, right, my explicit equation of an arithmetic sequence, right, given that my first term is a sub 1, its output can be written as follows. My output, a sub n, of my nth term is equal to a sub 1, my first term, plus n minus 1, the output, the placement of the number I'm looking for, minus 1. So if I was looking for the 20th term, for instance, I would put in 20, and then I would take 1 away from it, right? times d, our common difference. Well, if this seems slightly familiar to you, it's because it is. A sub 1, A sub 1, 1, 1. You could think of this as my output equals the y of my input plus my slope times x, n, minus x sub 1, my input. Okay, so very, very similar. We did this back in the past when we did lines of best fit, or if you have 2 points on a series of data and it's kind of messy and you just want to come up with a linear equation, this is a great way to go about doing that. So here is an example. Our sequence is 2, 11, 20, 29. So D, my common difference, equals 9. My A sub 1 equals 2. Okay. So A sub n is going to equal A sub 1 plus n minus 1, the quantity, times D multiplied by D. Let's say I want to find the 50th term. So I plug in 2 because it's my first term, plus 50 minus 1 is 49, times my common difference of 9 gives us an output of 443. So I could build this recursively and build it step by step by step to get out to that, or I can use an explicit equation that I generate to come up with the term 50 is associated with 443. Okay. Page 2, here's another example. 13, 8, 3, negative 2. You to fill in the common difference here and see if you can find, if I hadn't already emailed you a copy that looked like this. A sub 25 is what? Try to come up with an explicit and then check it against my answer. Try to come up with a recursive and then check it against my answer. Okay. Example, find an arithmetic sequence whose first term equals 5 and its fifth term equals 11. Well, that's kind of tricky, but I think we can figure it out. If I know that I'm looking at an x that is representative of the placement of the term and a y that's representative of the output of the term, I can find my common difference because all I'm really looking for is slope, right? So this can be represented as the 0.15 and this can be represented by the 0.511. And I can figure out that my change in y is an increase of 6 and my change in x is an increase of 4, giving me a slope of 3/2. Okay. So if I know that my common difference equals that, you can come up with a recursive function or an explicit function. See if you can do it first and then look at the answer. We're going to go over arithmetic means in the next video.